you very much. We are sorry. We are very sorry to keep you waiting. Today's session. Okay. Today's session. Single sign-on services with free open source software. It's wrong. Sorry. Jasing, CAS, and Hydra as SSO services. Tonny and Sabastian. Please welcome.
Thank you. Good afternoon, everyone. Thank you for coming today for my session. And this is the second time I come to an open source conference. The first time was in Depok, in my university, University of Indonesia. I was one of the collaborators for the conference with Asia 2015, and it's really honored to come to this conference, and thanks to openSUSE for this conference, and also friends at UAC. Okay, in my session, I want to share knowledge sharing, it's kind of experience sharing, how to build a single sign-on service with free open source software. I think maybe some of you, or maybe all of you, are using this kind of services where we know, like Google account. There's a kind of single sign-on services, also an education. We got federated single sign-on like EduRoam. This is my experience and how to build it with open source software. Okay, our outline will be my introduction, the understanding SSO services and the security aspect. Also, I want to share how we develop or we deploy our services at my university, the University of Indonesia. And also, this is my startup called Peentar, and maybe something we not covered. This is a very broad topics, and I cannot cover it at all at 30-minute time. Maybe I will set up later also if I got another chance for a conference. So this is me. I'm a system engineer at the University of Indonesia. So now I'm a chief of network administrator, and also I'm a volunteer for our national open source repository called Kambing. The pinyin is a goat. Wedus is the Japanese language for the goat. So it's Wedus or Kambing University of Indonesia. So after a lecture, I teach at my university at the Faculty of Computer Science. My subject is comprised of distributed system, system programming, and open source software development. And I also developed a startup called Peentar. This is Peentar.id startup. I'm a DevOps chief there from 2015 until now. We focusing on IoT, user platform, and e-health through our omnichannel system. Okay, that's a little introduction from me. So the first chapter is the understanding SSO and its security aspect. Okay, I think some of you already know the single, in short, SSO services occurs when a user login into one application and then sign in into another application automatically, regardless of the platform, technology, or domain where this user came from. There's a trust party. We have trust one party as the identity provider, and the party also provide you encryption for the identity channel to the communication between your apps and the services. On the contrary, single sign out. Yeah. If you log out from one application, then everything will be logged out. Maybe Google is the one of the easy example. When you log out at the Google Docs and your mail got logged out, your YouTube got logged out. Okay. This is a single sign-on flow. The most access mechanism involved on several parties. There's a user here will provide who own the credential Then there's a identity provider. The identity provider is a party or a server, a system you must trust in the system. So this is the vital point of the system. You have to harden it, you deploy to handle authentication, but sometimes also handle the authorization and auditing or AAA, authorization, auditing, and authentication. So also we have the requesting apps as the consumer of the identity provider. So this user will grant access right through the identity provider, and the requesting app will ask the credential from the identity provider. So the flow is 5 parts. The first time is user access an apps protected by SSO system. These apps, and then it got redirected back. And 2, 3. See, the apps will redirect back to the identity provider side. User access the identity side, then he or she entered their credential. User kind of like password, username, maybe other type of credential. Then identity side give user access right and several other attributes for application access. Then user sign in to the app with his or her access right and the attributes. This is the common flow of a single sign-on system. So for the backend, the IDP is the major component of SSO system. It can store and retrieve the credential and also access attribute from multiple backends, such as you can use directory services or the LDAP, OpenLDAP, for example, or Active Directory. So you can also store the credential on SQL database, and maybe you can use external service provider. There some protocol involved, OAuth or maybe SAML, SEML. The external service provider called Google account, OpenID, or predefined web services. You can define your own web services, which can be used by the IDP, the identity provider. Okay, the security aspect. We by implementing SSO, we expect several things. The SSO prevent credential theft on the application as long as the app uses SSO protected authentication. So we don't give the apps direct access to the credential database, but the SSO services will become the proxy for the apps to access the credential, and also give right for the app which can be used or which cannot be used. So SSO prevent authentication session link. So if we handle authentication per apps, maybe if you're not securing your apps correctly, someone injected your app and they stole your credential. So SSO can prevent authentication session late because IDP holds your authentication session. No, SSO will protect you on credential theft caused by malware, social metering, or keylogin gets out of bound. These are some free and open source software SSO implementation. I have tried 2 from these 4. The first one is Apparel Jasing CAS, or the Jasing. It's not Jasing, but Jasing. It's for Java Implementation Special Interest Group. This group is from Yale University. They are the initiator, and they also make this protocol called CAS, Central Authentication Services. This is a web-based authentication protocol. We will talk also about that later. And it's licensed mostly on Apache 2.0. And this is only Hydra. This is a new one we use at the Peentar. This is also Apache license 2.0. So C-Wallet, I think maybe university who implement a Jerome must known C-Wallet. This is also the SSO provider. Then Vessel 2 also has the identity server. So this is called the Apache License 2.0. These are some implementation of the single sign-on service you can deploy, and these are of the free and open source. But my talk will share my experience in deploying these two, the Jasing and the Hydra. It's not the Hydra, the enemy from Marvel Comics, is the Hydra from Ori. Okay, single sign-on at Universitas Indonesia, or UI. These are some profile of my university. One of the oldest state-owned university we established in 1849 by the Dutch colonial as the first time of the school for Japanese doctor, and then we become university after the proclamation. I think it's between 1950 and 50. Currently, we have more than 47,000 students, active students, from undergraduate and graduate students. So 47,000 from these 47,000 students, maybe at least 55% is undergraduate student and vocational study. So we have also more than 6,000 staff at the faculty, at the university administration, IT department for faculty, and lots of. So we have 14 faculties, 1 vocational school and 2 international graduate schools. Then we have more than 227 study programs. We are in Depok and Jakarta. The Jakarta 9.4 hectare is located in central Jakarta called Salemba. And in Depok, this is the largest campus, 320 hectare. We implement free open source software as most of our services. Yeah. So we have lots of the academic information system, the student e-learning system, our infrastructure. Here we build our routers mostly from the open source and do not buy proprietary one. We develop it ourselves. So that's all. Our single sign-on service, also the open source. We believe that collaborative work and cost are easy to enhance and obtain new things compared to a cost proprietary ecosystem. Even this belief on our engineer is strong. There is something sometimes we have to clash with the administration abroad. We don't live with a benevolent dictator from proprietary ecosystem. And also we are maintaining one of national free open source repository server at the company. Okay, and this is our single sign-on system. So UI, we start to use OpenLDAP as credential provider for students and staff at least during the early 2000s. So at this time we have single account, but authentication jungle. So every faculty will make their own system, maybe their own learning support system must query the DB. So the DB must also replicate it to the faculty. Every app has to build their own outsource to open LDAP. This will cost credential database. At 2010 and 2012, so I started using at 2011. So I involved in the later phase of the development. So I inherit the development from my previous team. So we're exploring a solution for a single sign-on system. When there are many apps, you can use a authentication platform, a common authentication platform of the apps. We deploy a single sign-on service on SSO Security Aspects. I will show the web. This is the web page. Using Jasing 3.4. So Jasing also provides you with customizable authentication portal. So it has standard portal, but we customize. This is the customization result. And at the first time, we are using OpenLDAP as credential source. And then, between this year, we upgraded to Jasing CAS 3.5X. And during this time, widely used on UICAS infrastructure such as internet access, our scholarship application system, journal access proxy, even we have the Microsoft Office too. So the campus want to buy some of the license for the student. And what they want. So we have integrated the SSO system to the Office, and also Google Apps. I will show you later. So per second, we handle several hundred authentication per second during peak hour. There's a lot of sessions. For example, our hotspot system during that peak hour, we handling more than 15,000 IP session on the router. Then also the people active and login and log out during the session. We also develop a guest account credential. So this is called akun tamu, guest account. This account was not accessing the LDAP, but we are using SQL database, and we hack the Drupal source, the Drupal database for our account. So this is the one of the source, and we also develop additional login attribute provider based on REST web service. Why? Some system maybe need more attribute that can give by the LDAP, such as maybe the scholarship application system. It will query, it will ask the student payment status. So the LDAP, they don't have student payment status because it is directory services. So we have developed additional REST web service as the CAS Backend. 2017, we are planning for the backend refactoring and update to CAS 5X. Why? Because there's more easy integration on CAS 5 especially to the REST web services, and also CAS 5 support for OAuth authentication. The CAS 3 don't provide OAuth, but they provide some like the CAS protocol and the SAML, and also CBOT. This is our stack and architecture. For now, the production is still running Jasing CAS 3.5.2. So we're running Tomcat 7 for the app server and Java 8. I recommend Java 8. So if you put too many attributes to the that will be given to the CAS, I'm experiencing some of memory leaks. So and how much memory you give to the server, it will make no sense because the memory consume rate is too high on Java 6 and Java 7. But I think the Java 8 is more friendly on their garbage collector. So we're running on Debian JC, the backend, and this is the backend for the credentials with OpenLDAP, code handler, and SQL-based code handler. This is for the guest account. So there's a guest account for a visitor to university or event. The account come from the Drupal. So we also build our custom REST-based service. For the services we have Adhi. This is the middleware. It's going to manage system and give the appropriate attribute for the hosting apps. Why? Some apps need in-depth attribute checking, such as student enrollment and payment status, and soft attribute cannot be given through LDAP. This is how we deploy. So the CAS server is a Java app. It uses a Spring framework. So you have to compile it by a Java way using Maven or Gradle. It will result on a WAR file. The WAR file you deploy in Tomcat, and also you need an SQL database also. But this is not for authentication handler or for ticket registry. I will show you later what is the ticket. The ticket registry, I don't know, it looks like CAS 5 already provided storage for the ticket registry, not by using a PostgreSQL base, but using a in-memory database. Because we don't have to store the tickets always. So maybe we need to track the login for at least 1 day, and you can drop the ticket. So this database always in the clean state every midnight. I will clean it. So compile CAS source code using Maven or Gradle in order to build WAR. This is the deployable form web overlay. So Tomcat, and deploy the WAR on your Tomcat server. There's two configuration files very important. First, the database identity database connector and the attribute provider. It can be edited with this file. Cannot show you the whole file, is quite long. So at least we also register the apps. The app who use the CAS server. Register the CAS server, and at least the last part is to secure your CAS server. Yes, the transaction must be secure. The ticket parts exchange within the system token must be passed to a CAS proxy, a HTTPS. I deploy Nginx in front of my Tomcat. Oh yeah, this is about the CAS. The CAS protocol. CAS is a HTTP-based authentication and authorization protocol based on the ticketing mechanism. So when you use CAS to securing your login, so it will generate some tickets. CAS involved in the two component authentication. The first, the CAS server. You deploy alongside Jasing CAS installation. Yes, the Jasing CAS is the CAS server, and under CAS client, you must include the client or embedded the code within your application. So the CAS client is there's a lot implementation you can find on GitHub. The CAS client library is implemented in most of the programming language, found on Python, PHP, .NET, Golang, and much more. And this is the ticket who is changed between the CAS server and the app. First, when you log in, it will generate a global session ticket for the TGT, or ticket granting ticket. It's like when you buy ticket tulisan ticket you buy a ticket at an amusement park, and you can play all the games on the park. The version of TGT like that is the master ticket generated by the CAS. And this is per application ticket. So if you the TGT will generate a service ticket per application. We use the same credential. So ST service ticket translated subject parameter URL stands for the access granted by the CAS server to the CASified. You mean the CASified application is the application where you embed the code from the CAS client library. This is the scheme. There's several phases on the CAS protocol. There's a first access called the get. When you use the CASified application, the application will redirect you to the CAS server. The product app will redirect you to the CAS server, and the CAS server presented you with a login form. If you enter your correct credential, it will generate a TGT, the ticket granting ticket. Then the ticket granting ticket will generate a service ticket for the application. The service ticket and then come to the user, store as a cookie, valid as long as the user login. So the user will get his session and access to the apps. That's the first access. And the second one, 5 minutes. Second access to the same application. You don't present it, the chat system, we don't present the application, the login form, but you will be redirected. Okay, I will pass. Sorry. Okay, this is a demo. So this is Google Apps integrated to our university. Present it. The Google Apps request a SAML to our task, and I will be login in here. So it will be directed to the Google Apps, and then if another application using, this is our project management called Kelola using Redmine. There, I'm logging like that. So this is the second access. The service ticket consumed by the Redmine and the Google. Google request the service ticket via SAML protocol. So if I log in here, sorry, the Google is not implemented the single sign out, but there's some application, another application I can demo because of time. Okay. Yeah, this is how you register service to just support registry such as YAML based. So basically, you register every services who want to use CAS and specify what attribute can be consumed by the app. So as maybe you can give their username, an email address, or phone number, or maybe this status mahasiswa, student status. For example, an active student or a student with the academic sabbatical. So something like that. This is the service registry. The second one is at Peentar. This is my startup. Yeah. I'm developing a startup called the Peentar, and we developing 3 products. We focus on IoT services, on the channel engine and Peentar integration. But in here, I also develop some federated login called the Hydra. This is SSO service, but is using an OAuth protocol, the OAuth protocol for the federated login. So in this system, we built the consent apps because the Hydra do not provide you with from login and how to handle authentication. Hydra is only provide you with the authorization because it's an OAuth provider. So deploy Hydra, some tutorial here. Basically, we need Postgres DB server. We need to compile the source or the Hydra. It's based on Go. We doing DB migration on the Hydra, and also first-time server implementation. It will generate your OAuth properties as the first OAuth client and OAuth client secret. So it will keep the file on the Hydra YAML. It will be used on the server startup. Also, we need to deploy same SSL services in front of Hydra. This is the Hydra client. So after the service, you develop the client. You must run a client, and it will set up your first our client for the management of creating and destroying apps with the Hydra is JWT, JSON Web Token to sign the OAuth request. I think the overflow thing. The user agent call the client app, and the client app call the Hydra, and this is where the authentication, the authorization comes, and the representing Hydra will directly to the concerned app, handling the authentication, and return it to Hydra and will start the OAuth session. So it's face. This is the part that I not covered. Because the topic is really broad, I cannot give all the detail. So maybe if I have another chance and another conference, let's have meet there, I will set up a workshop. I will telling about the Jasing or maybe Hydra without deployment. Also adding and removing backend service for attribute resolution and how to integrate the UICAS and Hydra application to your service, and also tune with Hydra. Okay, thank you. Is this time up? If you have any question, you can contact me at the...
Yeah. If you have any question, please ask him. Okay. Okay, thank you very much.
Thank you very much.